So we are going to start the second section of Chapter 4, which is going to be solving more complex quadratic equations. So the biggest difference between the last time we met and solved quadratic equations and this time is that the equations or the expressions that we're going to be factoring, if you look here, like my a value, remember this is always in the ax squared plus bx plus c form. In the first section, the a value is always 1, and it made it actually pretty simple for us because we would just be able to figure out what numbers multiply to c yet add to b. Now we also had a what do you call it? We had an activity where we went through and we kind of figured out that, you know, when that a value is not 1, we have to start rethinking about how we rearrange our x squared tiles. And so that causes just a little bit more complexity in the problem. So what we're going to do today is we are going to go through and we are going to factor these. Okay, the biggest thing that you're going to need to recall or remember just in general is that when you're factoring these, you always take out the greatest common factor. Okay, so you should always be taking out the greatest common factor. So what is the greatest common factor? Well, let's take a look. In this problem that we're doing here, we have 12x squared plus 44x plus 24. The greatest common factor is, simply put, the largest number that's going to divide evenly out of every single one of those numbers. So I'm looking at 12, 44, and 24, and I need to think about, well, what number divides evenly out of all of those? Well, to me, the most obvious one is 2, right? We can take a 2 out. So we take a 2 out of 12 and we get 6, and we take a 2 out of 44 and we get 22, and we take a 2 out of 24 and get 12. But that doesn't mean it's the greatest common factor. So we're looking for the largest number that divides evenly out of all three of those values. So as I look at this, I think I see pretty, I think 4 divides into 12, and 4 divides also into 44 and 24. So I'm going to go ahead and see what happens when I just divide a 4 out of each of these. So I'm going to divide a 4 out of all 4 parts, or all 3 parts here. So if I divide a 12x squared by 4, what's going to happen? I am going to get 3x squared. And what about if I divide 44x by 4? I'm going to get 11x. And 24 divided by 4, well, that's just going to be 6. Okay. So greatest common factor, you always have to check. It's not always necessarily there. Sometimes the largest value you're going to have that's going to divide out of those is just going to be 1. But that just means there is no greatest common factor, really. Or to be taken out, I should rather say. Okay, so this is what taking the greatest common factor out of every one looks like. Okay, so when your a value is 1, so we already have one method of factoring. The first is multiply to c, add to b. That only works when a is 1. Okay, now we're going to move into when a is not 1. When a is not 1, when a does not equal 1, use the Xbox method of factoring, okay? And I will walk you through the Xbox method. Okay, so after you take the greatest common factor out, we actually can kind of temporarily forget about the 4, and we're really only focused on factoring what's inside my parentheses here. I had just underlined it. So what we're going to do is we're going to set up an X. That's the X part of Xbox, right? And what you want to do is you want to put your a times c value here and your b value here. My new a, b, and c value. So what is my b value here? So my b value here would be 11. So that's what's going to go into the top. My a times c, well, my a value is 3 and my c value is 6. So that means my a times c value would be 18. Okay, and so then now I just have to figure out what's going to go in these slots, okay? And this is what's nice and consistent with the previous method, is a lot of times we're just looking for numbers that multiply to C, add to B. Well, now, instead of multiply to C, add to B, we're looking for numbers that multiply to A times C and add to B. So I'm looking for the combination of numbers that multiply to 18 but add to B. So if you don't know, you should start listing the numbers that multiply to 18. So my first combination is 18 and 1. And there's no way that's adding to 11, so I'm going to move on to the next one, which is 2 and 9. Well, this does work, because if I go 2 times 9, that's 18, and if I go 2 plus 9, that's 11. So I'm going to put 2 and 9 here, and those are completely interchangeable. Okay, so, one second. Okay, so then we can move on. Once we found this combination here of what numbers multiply to A times C and add to the B value, then I can go ahead and use the box method here. In the box method is, we've seen it before, of multiplication. And so that's where we have these outside parts, and then we figure out what they multiply to. Today is just going to be the opposite of that. So what we're going to do is we are going to fill the inside of the box out, and we're going to figure out what's going to go on the edges. Okay, so we're going to go, the ax squared term goes here, and our c value term goes here. Okay, so ax squared for me looks to be 3x squared. So I'm going to put that there. And then the c value term looks to be 16. Now, it's a pretty common mistake for people to put 18 here, because that's what we got here, but I want the original c value term. Okay, and then this 2 and the 9, this is where the 2 and the 9 are going to come into account, is they're going to go in these diagonals, okay, with an x attached to it, because really what I'm doing is I'm just reconstructing 9 or 11x into 2x plus 9x. So I'm going to go ahead and put 2x here, and I'm going to put 9x here. And again, those are totally interchangeable. Now what I can do is I can start, I want to try to figure out what my length and my width of my box are going to be when I have the entire area, just like the tiles that we dealt with. Okay, so the way you can accomplish this is you can go ahead and look horizontally and vertically. Okay, and we're going to try to figure out what is the greatest common factor. So the largest value that divides out of each of these, okay? So as I look at these, okay, I'm looking at 9x and 3x squared. So the easiest way to approach this to me is look at the numbers first. So I have 3 and 9. I'm looking for the largest number that divides evenly out of 3 and then also out of 9. Well, 3 divides out of 3. And 3 divides out of 9, both evenly. So 3 is going to be my one part of my greatest common factor. Okay, the other part here is there is a variable of x. So x squared is x times x, and 9x is just a single x here. So it looks like I have a common factor of just one x here, because this has x times x, this has just one x. So I can divide out an x here as well. Okay. And then now I can still do the same thing, but on the bottom here. Okay, I'm looking for the largest value that divides evenly out of each. So I have 2 and 6. You're going to look at the numbers first. So the largest value that divides out of 2 and out of 6 evenly would be just 2. Okay, now, when we have our x's, okay, like up here, we pulled an x out every time, or we pulled an x out here because we had an x in each term that we were taking the greatest common factor out. Here it's a slightly different, because I have a factor of x here, but I don't have a factor of x here. So ultimately, what that means is that there's no common factor of x, meaning that that is not part of the greatest common factor. Therefore, this 2 is just our greatest common factor. Okay, now what we're going to do is we are going to go ahead and we're going to take out vertically. So we have 3x squared and 2x. So I'm looking at the numbers, and what's the largest number that divides out of 3 and 2? So we have to think about this. The largest number that divides out of 3 and 2. So 2, the numbers that divide into that would be 2 and 1. but 2 doesn't divide into 3 evenly. And then the numbers that divide out of 3 are 3 and 1, but again, 3 doesn't divide out of 2 evenly. So what does that mean? That means that there's just a greatest common factor of 1. So we're going to have a 1 here. And then again, we have the same kind of concept here. We have an x squared and then another x. That means I have a factor of x here. Okay. And then here I have to look, and I have 9 and 6. So I'm looking at the numbers that divide evenly out of 6. So that would be 1, 2, 3, and 6. Well, what's the largest of those that divides evenly into 9? So 1 does, 2 does not, 3 does, and then 9. So it looks like we have a greatest common factor of 3 here. That's the largest number that divides evenly out of that. So right here are my factored terms. So now I have 3x plus 2 and x plus 3, but what we cannot forget about is this original 4 that we have here. So 12x squared plus 44x plus 24 factors all the way into 3x plus 2 times x plus 3. Okay, so let's go ahead and, or I guess one thing I should elaborate upon here is that this statement here and this statement here are mathematically the exact same. They have the exact same meaning and value. Okay, let's go ahead and go to 2. So this one here, we're going to check first for greatest common factor. So I'm looking at 2, 1, and negative 1. So I'm looking for the largest value that divides evenly out of all of those. So as I'm looking at this, I have pretty small numbers. I have 1 and negative 1 here. So I think that this is going to be our largest value is just going to be 1. So there's no greatest common factor here. Okay, so what I can go ahead and do then is I can go ahead and just start my Xbox method. Okay, we're going to have 1 here. That's my B term. And then I'm going to have negative 2 here because that's my A times C term. So then now I need to figure out what numbers multiply to negative 2. Okay, so then, I'm going to have some combinations here because I'm looking for numbers that multiply to negative 2 but add to 1. So I could go, for example, negative 2 and positive 1. Negative 2 and positive 1, those multiply to negative 2. Negative 2 times 1 is negative 2. But then negative 2 plus 1 is negative 1. So this is not my combination. So then I have to go and try the other way around. What about negative 1 and positive 2? So here, negative 2 times, or negative 1 times 2 is negative 2. But negative 1 plus 2 is positive 1. So this indeed is my combination. Okay, let's set up the box. Okay, I'm going to have 2x squared here. And then I'm going to have negative 1 here. My ax squared term, ax squared, and my c term here. Okay, and then I got to go ahead and put these in my corners here with an x variable attached to it. Okay, and then and now I'm going to start taking out the greatest common factor. Okay, so let me peek around here and see if I have my cheat sheet. Looks like I do not, but this is fine. So what we need to do here is we need to understand that there's times where I'm using my box method that I'm going to have to take a negative number out. So what I think everybody should do is you will have a pink cheat sheet, which I just don't have here on me at this moment. And what we will do is create a when to take out a negative. Okay. Okay, when to take out a negative. So here, if I have a box here, and this is my box here, and I have a positive number here, a positive number here, and then negatives here. Okay, I will be taking a positive number out here, a positive number out here, a positive number out here, and a negative number here. Okay, basically anytime you're going to have two negatives in a row, you're going to be taking out a negative. Okay, and then what's essentially equivalent to that is, what if I have a positive number here, a negative here, a negative here, and a positive here? Okay, so this is kind of like the box just turned on its side. Well, it's going to follow the same principle, right? I'm going to take a positive here, a positive here, a positive here, and a negative here. Okay, two negatives in a row, you're going to end up taking a negative out. There is one other situation where this is going to be impacted, okay? And that is when your corners are positives and your other corners are negatives, okay? This would be like an example where you're going to have a negative number times a negative number results in a positive, okay? So this means I'm going to have to take negatives out on each corner, okay? And then positives inside. So these are all the different situations when you're given the box method or doing the box method where you will have to take out negative numbers. Okay, so essentially to me it's the double negative rule, right? Anytime I have a double negative, I'm going to end up taking out some negatives. The only tricky one is when you have corner negatives, you will have to take out two negative numbers. Okay, so let's look at this situation. So where am I going to be taking out my negative number, right? So let's think to ourselves, am I going to be taking out in the upper right, in the lower left, or am I going to be taking out in each corner? Okay, I have two negatives in a row, so I'm going to be taking out a negative number right here and here only. Okay, so I'm going to put that negative there just so I don't have to worry about it anymore, and now I can just move forward with the same process as what I've been doing. Okay, so let's go ahead. Greatest common factor. Greatest common factor of -1 and negative x. Well, I know I'm taking a negative out, but they don't really have much in common, right? They just have a 1x and a -1. There's no x term here, so that tells me it's just going to be a common factor of 1. Okay, so let's go here. 2x squared and 2x. They both have a common factor of x. Okay, they both have a common factor of x and common factor of 2. So I'm going to take out a 2x. Okay, vertically, common factors of -1x and 2x squared. Well, they have a common factor of x. And as far as the numbers go, they really don't have a common factor beyond that. Okay, and then here we have -1 and 2x. So here I'm looking at this and saying, hey, -1 and 2, the largest number that divides out of those is 1. And there's not a common factor of x in both, so I can't take that. So 2x squared plus x minus 1 is equivalent to x plus 1 times 2x minus 1. This term and this are the exact same thing. This is just what we would call considered factored. Here's the good thing about the Xbox method is you can always go back and check your work. You can see if you were to use the box method of multiplication, it should work out like 2x times x is 2x squared. 2x times 1 is 2x. X times -1 is -x. -1 times +1 is -1. And then when I combine these together, I get -x. Okay. I think right now is a good moment to pause the video on your own and go ahead and try A and B on your own, and then check it with me when you are done. So I'm assuming that we've already tried it on our own, and you're just here to see how you do. So I'm looking at this. There's no greatest common factor. There's not a number that divides evenly out of each of these, so I could just go right into my Xbox method. I'm going to put 8 here and 15 here. So now I'm looking for the numbers that multiply to 15 and add to 8. I may not know that right off the bat, and if you do, you can just go ahead and go. But if you don't, just start listing them out. So 1 and 15, there's no way that's adding to 8. So then 2 doesn't divide into 15. 3 does divide into 15. And that should just be a 5. So 3 and 5 Well, those multiply to 15 and add to 8, therefore that's my combination. Okay, so I'm going to have 5x squared here, and I'm going to have 3 here. I'm going to have 3x here and 5x here. Okay, no negatives, so everything I'm taking out is going to be a positive. So I'm looking at 3x and 3, and that largest value that divides evenly out of that is 3. 5x and 5x squared, I have a common factor of 5. I have a common factor of x, so I'm going to take out a 5x. 3x and 5x squared, well, I have a common factor of x, and 3 and 5, the largest number that divides into each of those is 1, so that's just 1x. 3 and 5 again, the largest number that divides evenly out of those is just 1, so just plus 1. No x because there's no common factor of x. Meaning that 5x squared plus 8x plus 3 factors into 5x plus 3 times x plus 1. Okay, let's move to letter B. Okay, letter B, this does have a greatest common factor. Okay, so, I'm not 100% sure what's dividing into 62, so I'm just going to start by taking a 2 out and seeing what happens. So I'm going to say this is 6x squared plus 31x minus 11. Okay. And then I can just look at the smaller numbers like 6 and 11, like 1, 2, 3, and 6 all divide into 6. And only 1 divides into 11. So that means I did take out the greatest common factor. So I'm going to start my X box. I'm going to have 31 here and negative 66 here. Okay. So this one's might be a little more complicated. So I just want to write 66 down. I want to figure out what numbers divide into 66. So you're going to start with 1. 1 and 66. So one of these numbers to multiply to a negative is going to have to be negative. So if one of these is negative and one of these is positive, is there any way I'm getting to 31? Answer to that's no. So then we can just move on to, what's the next number that divides into 66? Well, that's going to be 2. So I have 2 and 33. So again, one of these numbers is going to have to be positive, and one of these is going to have to be negative. So is there any way I can get to 31 from 33 and 2? Yes, there is. If I have a positive 33 and a negative 2, 33 times negative 2 is negative 66. 33 plus negative 2 is 31. So I'm going to have 6x squared and negative 11 here. I'm going to have 33x and negative 2x. Okay, let's go ahead and just determine right away where am I going to take a negative out so I just don't have to worry about it. So let's get a little cheat sheet out. Yours is the pink one that's already been laid out for you, but if you just made one like this for yourself, this is fine. So I'm looking for either corner negatives or 2 negatives in a row. Looks like in our problem we have 2 negatives in a row. So I'm going to go ahead and pull a negative out right above it. Okay, so let's go ahead and do this. Largest number that's going to divide evenly out of 11 and negative 2x is 1. Largest value that's going to divide out of 33x and 6x squared. Well, they have a common factor of x, so let's just go ahead and take that out of there. But then, I'm not really sure what divides out of 33 and 6, so you might have to go through and start thinking a little bit. You get a calculator out. So let's look at 6 first. 1 divides into 6, and so does 6. But does 6 divide into 33? No. So what's the next largest number that divides into 6? It's 3. Does 3 divide into 33? Yes, meaning that's going to be my greatest common factor. Okay, now we can go horizontally. 6x squared and negative 2x. So I have a common factor of x. And so now I'm looking at each of these, and, well, 2 divides into 2. That's the largest number that will divide into 2. And that also divides into 6. So that's going to be my greatest common factor. Furthermore, 2x times 3x is 6x squared. Okay, and then lastly, I have 11 and 33. Okay, so the largest number that divides into 11 and into 33 is just 11. So 12x, or so this part here factors into 2x plus 11 times 3x minus 1. And then I can just go ahead and take my 2 down here. Okay, so 12x squared plus 62x minus 22 is equivalent to 2 times 2x plus 11 times 3x minus 1. Okay. Okay, let's just go ahead and continue to get more practice with this. All these problems get the same approach, essentially. Okay, so let's go ahead and look for greatest common factor. There is none. All right, because I'm looking at 4. Numbers that divide into 4 are 4 and 1 and 2. None of those divide into 9. So I'm going to start my x. I'm going to have a times c here, which is 4. This is going to be negative 15. And this is going to be, well, let's think. 4 times 9 is 36. Okay, so now I'm looking at this one, and I got to figure out numbers that multiply to 36 but add to 15. So let's go ahead and start with our first combination, which is 1 and 36. That's not getting to 15, so then we're going to have to move on to 2. 2 and 18. 2 and 18, I mean, I can get to 20 and to 17, but not to 15, so that is not my combination. 3 and 12 is my next combination. Well, 3 and 12, I mean, I can get to 15, but negative 15 might seem like it'd be a little bit of a problem. So this is one where you have to understand, what are we multiplying to? We're multiplying to a positive 36, but we're adding to a negative. So what are the only ways to multiply two numbers together and get a positive number? Well, the first would be if both numbers are positive. The second would be if both numbers were negative. So that's our situation here, is that I am going to have a negative 3 and a negative 12. Okay, so whenever you're multiplying to a positive and adding to a negative, each of these are going to have to be negative. Okay, I'm going to put 4x squared here. I'm going to put 9 here, negative 3x here, negative 12x here. Okay, then I want to check, where am I going to take negatives? Well, I have negatives in each corner, so let's refer to our sheet here. I have negatives in each corner. Whenever I have negatives in each corner, I'm going to pull negatives out in each of those. So I'm going to take a negative out here and a negative out here. And this is why my negative times a negative will result in a positive. So the largest value that divides out of 3 and 9 is 3. Largest value that divides out of 4x squared and negative 12x. Well, 4 divides into 12, so there's going to be 4. And they each have a common factor of x, so I'm going to have 4x. Okay, then here, 4x squared and negative 3x. Well, 3 and 4 only have a common factor of 1, but x and x squared have a common factor of x. Lastly, 9 and negative 12x have a common factor of 3. That's the largest number that divides into 9 and into 12. So this factors into 4x minus 3 times x minus 3. Okay. Number 4. Okay, kind of same process, right? Greatest common factor, 8, 14, and 9. None, right? Because, like a 2 would divide out of each of these, but it doesn't divide evenly out of 9. So I'm going to set up my x, which is going to be negative 72. And then this will be negative 14. Okay, so this seems like this is going to be a little bit trickier of one. Okay, so here I am going to have 1 and 72 as my first combination. And I'm multiplying to a negative, so one has to be negative and one has to be positive. So there's no way I'm getting to 14. The next one would be 2 and 36. 2 and 36. Okay, and now there's no way that's getting to 14, so that's not the combination. So what about 72 and 3? So does 3 divide into 72? I think it does. So I get 3 and 24. 3 and 24. I mean, that's not getting to 14 either. Okay, so we can go ahead and try 4 into 72. And now we're going to go 4 and 72, so that's 18. So 4 and 18. Is there any way 4 and 18 are getting to 14? Yes. Because if I go 18 minus 4, that's 14. But now we have to think about this because we know we have one problem. Well, we have one number that's going to have to be negative and one that's going to have to be positive. That's the only way to multiply to a negative. So we need to think about, well, which number is going to have to be negative here? Well, if we think about it like this, I'm getting to negative 14. So the number with the larger value, 18, is going to have to be negative. So I'm going to have negative 18 and positive 4. Okay, this is a great example of sometimes you have to actually work through a handful of these combinations till you get there. Okay, especially numbers that like 12 or multiples of 12, they divide by a lot of numbers, and so there's a lot of combinations. So sometimes you'll just have to work through a handful of these. Okay, so let's go ahead and do the box. Okay, 8x squared, negative 9. Okay, we're going to have negative 18 and 4x. Okay, I have two negatives in a row, so I'm going to take a negative out here. So I'm looking for the largest number that divides out of 9 and 18, which would be 9. Largest value that divides out of 4x and 8x squared. Well, 4 divides out of each of these commonly. That's the largest one there. And x and x squared have a common factor of x. Okay, 8x squared and 18x, they each have a common factor of x. And 8 and 18 have a common factor of 2. That's the largest number that divides evenly out of each of these, because 4 does not divide into 18, and 8 does not divide into 18 either. Okay, and then 4 and 9. So these numbers don't, 4 doesn't divide into 9, 2 doesn't divide into 9, so it looks like it's just 1. Okay, so this factors into 2x plus 1 times 4x minus 9. Okay. So these problems, they have a little bit more steps than the previous ones we did, but they have some similarities. We're just trying to find these combinations of numbers that multiply to one and add to another. Okay. Pause the video now and move on to C and D. Check it with me when you are done. Okay, so I'm assuming that you've already tried these on your own and you're here just to see how you did. Okay, so there's no greatest common factor, so I'm going to have 10 and negative 11. That's an 11. Okay, so I got to get to 10. What's the first combination that gets me to 10? It's 1 and 10. Is that going to get me to 11? Yes. But I'm multiplying to a positive but adding to a negative, so each of these numbers are going to have to be a negative. Negative 1 times negative 10 is positive 10. Negative 1 plus negative 10 is negative 11. Okay, 5x squared here. 2 here. Negative x here. Negative 10x there. Greatest common well, I have corner negatives, so I'm going to take out negatives in each corner. So greatest common factor here between 2 and 10 is going to be 2. Greatest common factor between 5 and 5x squared and negative x is just x. Greatest common factor between 5x squared and negative 10x, 5 and 10, well, 5 divides into 5 and 10 evenly, so it's going to be 5, and then they each have a common factor of x. 2 and negative 1x would be just 1. So this factors into 5x minus 1 times x minus 2. Okay, and now for the letter D. Again, no greatest common factor, so we can just move right into the Xbox method. I'm going to have 14 here, negative 14 here, and negative 13. Okay, I need to figure out the combinations that multiply to me to negative 14 and add to negative 13. So 14 here, my first combination is 1 and 14. There is a way for me to get to negative 13. With this combination, that's when this is negative 14 and this is positive 1. This will be 2x squared. This will be negative 7. This will be negative 14x. This will be negative, or positive x, my bad. Okay, I have double negatives, so I'm going to pull a negative out. Greatest common factor here between 7 and negative 14, or negative 14x and negative 7 is negative 7. Greatest common factor here is just a factor of x. Greatest common factor here is a factor of x and a factor of 2. Greatest common factor between negative 7 and positive 1x is just positive 1. Okay. All right, so that section was long, but if you look at 1, 2, 3, and 4 alongside A, B, C, and D, that's every combination of positive and negative that we can have. Every single kind has just been laid out for you. So refer back to these examples if you're having problems when both numbers are negative, or one's positive and one's negative, or some other combination of that. Okay, let's actually solve some equations. If you recall from the last section, you want to find, when you're solving equations with exponents in it, specifically with exponent 2, we need to set them equal to 0 to factor. Okay, we want to set equal to 0 and factor because when we have it set equal to 0, we get two numbers multiplied together, and when we multiply two numbers together and my result is 0, that means one of the two have to be 0. So let's go ahead and see what that looks like. So here, this is already set equal to 0. Your first step always is set equal to 0, but this one's already done for us. So here I have all of this. Okay, so now I want to factor this so I can use the zero product property. So I'm looking for a greatest common factor, and there is none, so I can move right into the Xbox method. Okay, I'm going to have negative 12 here and negative 1. Okay, so I'm looking for numbers that multiply to negative 12. So I'm going to have 12 and 1. That's my first combination. There's no way these are going to add to 1, so I'm going to move on to 2. 2 and 6. Again, there's no way these are moving on to 2 or to 1, so I'm going to move on to 3 and 4. Okay, this combination can get me to 1 somehow. Okay, so we just have to think which one of these is going to have to be negative so that I multiply to negative 12 but add to negative 1, and that's when the 4 is negative. So here I would have 3x squared, I would have negative 4, I would have a negative 4x, and a positive 3x. Okay, and so then what I can do is I can, check where I take a negative out. I have a double negative here, so I'm going to pull that out. Here I have a common factor of 4. Here I have a common factor of 3. I also have a common factor of x. Here I have a common factor of x, and then these numbers only have a common factor of 1, so it's just going to be 1x. Here I have a common factor of 1 again. Okay, so now I'm just going to rewrite my equation. I'm going to have 0 is equal to 3x minus 4 times x plus 1. Now when I have parentheses around these numbers, that means that this is grouped together as one number. and this is grouped together as one number. And this is why you always set it equal to 0. And I've already explained this in the previous section, but it's so important that I'm going to explain it again. When I'm multiplying two numbers together and the result is 0, there's no way to multiply to 0 unless one or both of the numbers are 0. One or the other has to be 0. So what does that mean? That means either this number here is 0 or this number here is 0. So I can write an equation that says that 3x minus 4 is 0 and x plus 1 is 0. And then I can just solve. Divide by 3. Meaning x is going to be equal to 4/3 and x is equal to -1. So more times than not, you are going to get two answers, okay? Also, more times, especially in this section, you're going to get a ton of fractional answers. I want you to leave your answers in fractional form, okay? Do not give me a decimal. I just want the fractional form. Okay, let's move on to 6. Okay, so 6, again, the first thing, and let's write a little note. We always want to set equal to 0, and I want my a value to be positive. Okay, it's not that you can't do it when a is negative. It's just that it's like 1,000 times easier to do when the a value is positive. Okay, so what do I have to do to keep my a value positive? Should I subtract 4x squared and add 6x to this side, or add 2 to this? Well, the a value is already positive here, so I want to get rid of this -2 by adding 2 to each side. Okay, now it's set equal to 0. Now I want to check for a greatest common factor. So 4x squared, -6x, and 2. To me, it seems like all these numbers can divide by 2. So let's go ahead and do this. I'm going to pull a 2 out. 4x squared divided by 2 is 2x squared. -6x divided by 2 is -3x. Positive 2 divided by 2 is 1. Now I can just go ahead and try to factor this inside part. My a value is greater than 1, so I have to use the Xbox method. A times c is 2. B value is -3. I need combinations that are going to get me to 2 and add to 3, so 1 and 2. So I got to think about how am I going to multiply to a +2 but add to -3? Well, again, what is the only ways that we can multiply to a negative number or multiply to a positive number but add to a negative? Both of the numbers would have to be negative. So I'm going to have -1 here and -2 here. Okay, so let's go ahead and use the box here. Okay, I have corner negatives, so I'm going to pull out negatives in the corner. Greatest common factor here is 1. Greatest common factor here is 2x. Greatest common factor here is just x. Greatest common factor here is 1. So now I have 2 times 2x minus 1 times x minus 1 is equal to 0. Now what I can do is I can just solve each factor set equal to 0. Because again, if I'm going to multiply in this situation 3 numbers together, one of these two numbers is going to have to be 0, because there's no way this one's going to be 0. So x is 1/2. And x is 1. Okay, again, I'm going to ask that you pause the video and move on to E and F and try those on your own. So I'm assuming that you've already done this and you are ready to try these. Okay, so it's already set equal to 0 and there's no greatest common factor. So this is 66 and this is 17. 6 times 11. I do not know this combination off the top of my head. Okay. 2 and 33. 3 and 22. I don't think 4 divides into 66, and neither does 5. So let's go to 6. That would be 11. Okay, so there's my combination. Okay, so let's do my box. All right, so I'm going to have 11x squared, 6, and then 6x, and 11x. No negatives to worry about, so just greatest common factor here is 6. Greatest common factor here is 11x. Greatest common factor here is just x. Greatest common factor here is just 1. So here we're going to have 11x plus 6 times x plus 1 is equal to 0, which means that 11x plus 6 is equal to 0, or x plus 1 is equal to 0. So I can subtract 6. Divide by 11 to get x is equal to negative 6/11, and subtract 1 to get x is equal to negative 1. Okay, and again, leave that as fractional form. I just don't want the decimal. Okay. Okay, let's do the next one. The next one here, we have to set equal to 0, so you have to think about what's going to be the most convenient way to do that. Most convenient way is going to be add 6x squared and minus 36x. So now we're going to get 0 is equal to 6x squared minus 36x plus 30. Okay, this has a greatest common factor. Okay, this has a greatest common factor of 6. So I'm going to pull a 6 out to get x squared minus 6x plus 5. This inside part here is actually convenient for us. Look at this. My a value is now 1. So that means I do not have to use the Xbox method. I can just look for numbers that multiply to c and add to b. What's the numbers that multiply to 5 and add to negative 6? To me, I'm looking at that and I'm saying that is going to be negative 5 and negative 1, which means x minus 5 is equal to 0 and x minus 1 is equal to 0. Meaning that this one has two whole number solutions, 5 and 1. Okay. I think the 5th page of our notes, I'm actually just going to go over in its own lesson, so we can just kind of keep moving on here. So let's go ahead and do a word problem here. Okay, you plant an urban garden vegetable garden that is a rectangle. Okay. Here's my garden. The width of the garden is 8 feet and the length of the garden is 12. So this is a 12 by 8 rectangle. And I want to plant a border around the entire garden that will have the same width on every side. And the border will have the same area of the garden. Okay, what should the width of the border be? So I want to put a little border around this thing. Okay. And what they're saying is, I want this width here, this distance is here that I'm dashing in red. They want all of these to be the exact same length. But we don't know what that length is. So think to yourself, what would be the best thing to represent what we don't know? A variable. So a variable here would be like x. Like all these are going to be little length x, little red lines. Okay. So let's think about this. We know that my length times my width is going to be equal to my area. Okay, and so I already know, well, let's figure out what 12 times 8 is real quick. That's 16, and that's 96, okay? So we know, we got to think about what is my length here. Well, here I have length x plus length 12 plus length x. So what is this length altogether if I were to simplify this? X and x could combine into 2x plus 12. So here's my length. My length is now 2x plus 12 because this is little length x and this is little length x. There's my 2x's, but then there's this additional 12 here. Okay, so let's do the width. Okay, my width is going to be length x and length x plus length 8 plus length x. So what's this going to be? This is going to be 2x plus 8. Okay, so now I have my length and my width. So my length is 2x plus 12 times my width, 2x plus 8, is going to be equal to my total area. Now, I know this inside part is 96 because 12 times 8 is 96. But it does also state something in here that the border will have the same width on every side, and the border will have the same area as the garden. So if this is length 96, this is also going to be 96. So this means the total area is going to be 2 times 96. Okay, so my length times my width is going to be equal to my total area. Okay, so now the only way to solve equations like this is to have it set equal to 0, which we do not. So let's figure out what 2 times 96 is first. That's 12, and that's 18, 19, 192. Okay, so then we know that this is 192, but what about this? Well, this is a problem where we're probably going to have to expand this out to solve this. So let's actually do our box method of multiplication. 2x and 12, 2x and 8 to get 4x squared, 24x, 16x, and then 8 times 12, 16, 8, 9, 96. Should have known that. That's okay. So then we can combine all this together. So my new equation, after I multiply these together, I'm going to get 4x squared plus, that's to 30, 40x, plus 96 is equal to 192. Okay, so now, if we want to talk about like what I want to consider proficient in a word problem, I need you to be able to set up my equation. So I need you to get to about this step here. Okay, understanding to drawing a diagram I think is helpful. Understand that the border is the same width on each side. So I'm going to x and 12 and all of that. Okay, now the reason why I'm multiplying these together is so I can get the equation in a form so I can set it equal to 0. So to set this equal to 0, I'm going to have to subtract 192 to get 4x squared plus 40x minus 96 is equal to 0. Now I can start to factor. Okay, now I need to start factoring. I'm going to check for a greatest common factor. I think 4 divides into all of these. That gives me x squared. This gives me 10x. 96, I think this is negative 24. Okay, so now I can look at this, and now I'm trying to factor this equation here, and I'm asking myself, what number multiplies to negative 24 and adds to 10? Well, you know what? Honestly, in my own head, this is not popping up, so let's just go ahead and write 24 here. First combination is 1 and 24. Will that get me to 10? No. Next combination is 2 and 12. Okay, that can get me to 10, right? So which one of these has to be negative so that I can get to positive 10? The 2. So this will be x minus 2 times x plus 12. Then I'm just going to go ahead and finish my workup over here. Since I have 2, 3 factors being multiplied together to get 0, I need to know that each of these is going to be set equal to 0. So then I'll go ahead and add 2. Okay. So now I just have to figure out, these are my solutions to my equation. These are algebraic solutions. But that doesn't mean both of these are actual realistic solutions, because we're talking about a border and the length of a border. And a border cannot have a negative distance. We've talked about this concept several times in our class. So really only one of these answers can be true, and which one would that be? Thinking to yourself, you cannot have a negative distance, therefore 2 has to be my solution. And I want a quick answer. The width would be 2 feet. The width would have to be 2 feet in this situation for you, for the border and the inside of our garden to have the same area, or have a total area of 192 feet. Okay. All right, what I want you to do is I want you to move to letter G. I want you to try it on your own, okay? And I know with the word problems, they're often difficult, but I really want you to try to at least set it up before you go ahead and check what I'm going to do. So pause the video now and then move on to letter G. So I'm assuming you've already paused the video and you're just trying to check to see how you did. Okay, you want to build a rectangular swimming pool. With a width of 22 feet and a length of 18 feet. And you would like there to be a deck around the same around that pool with the same length on each side. Your back room yard only has enough space for 780 square feet of space to fit a pool and deck together. What's the maximum width the deck can be? So again, these are all going to be the same length here. Furthermore, we all know it's going to be same length x because we do not know what that length is. Okay, so this still has the same setup. We know the length times the width is going to be equal to my area. So let's figure out my length here. Okay, it's going to be length x plus 22 plus x. So x plus 22 plus x. That's 2x plus 22. Here, this will be length x plus length 18 plus length x again. So this will be 2x plus 18. Oops. So again, length x, length 18, and then length x again. To 2x plus 18. So here I know my 2x plus 22 times 2x plus 18 is going to be equal to my total area here. Now in the previous one we had to do a little bit of work to figure out the total area. This one tells me my maximum space here, which is 780. All right. Okay. So then now what we want to do is we want to multiply out that. So this is going to be 2x and 22, 2x and 18, 4x, 44x, 36x. I do not know what 22 times 18 is. That's 16, that's 16, 17, 396. Okay, just double check my work here. Okay. All right, so then now what I have is 4x squared plus, okay, this gets me to 50, so this is 80 together. All right, and then now I have to set equal to 0. I'm going to subtract 780. Okay. Okay, so I'm going to get 4x squared plus 80x. Alright, 780. 384. Now this one I'm going to struggle with a little bit, right? Because I'm not sure what the largest number that divides evenly out of this, so we can do it in parts. I see that each of these are even, so I'm going to try to divide a 2 out of each of these, okay? So this is going to be 4 at, or no. If I divide a 2 out of these, this is going to be 2x squared. This will be 40x. And this will be 384 divided by 2 minus 2, so that's 180, and that's 9, and 192. And then I see that they're all even again, so that means I can take another 2 out. So now I have 2 times 2, x squared plus 20x plus 192. so 96. And I did make a little mistake here, folks. It looks like this needs to be negative, and this needs to be negative also. Okay, so now I can just factor this here. I am looking for numbers that multiply to 96 and add to 20. Okay, so let's go ahead and just right up top here. I'll try to create a little bit of space here. Let's go 96. 1 and 96. Now there's not anything that divides evenly out of that. So let's go ahead and divide 96 by 2. That's 48. That's not getting me to 20. So let's try 3. That's 32. That's not my combination. What about 4? So 96 divided by 4. Okay, so that's 24. Now 24 will get me there. Okay, so now I just have to think what numbers are going to get me to positive 20 if I have negative 96. Okay, so let's finish my workup over here. So 4 times. Okay, so we know that my 24 is going to have to be positive and my 4 is going to have to be negative. So x plus 24 times x minus 4 is equal to 0. This 4 came from 2 times 2. So then x plus 24 is equal to 0, or x minus 4 is equal to 0. Subtract 24 to find x is negative 24. Add 4 to find x is equal to 4. And again, just like the previous problem, only one of these answers can be my actual answer, and that's going to have to be x is equal to 4 because we cannot have a negative distance. So the max, the width of the deck can be 4 feet. All right. All right, that's the end of this section. There is a little bit of review on simplifying square roots, but I think we took up enough time here